All right, so we're going to finish this up. It says solve the following inequalities, graph the solution set, and write it in interval notation. So we're going to start by noticing that my variable is here. Oh, sorry. I thought that I was highlighting. Variable is in this term, and then these terms don't have the variable in it. So I'll go ahead and start by adding or subtracting that 14 over. So negative 4 minus 14 is negative 18, is less than or equal to negative 2/3 p. And then when I multiply both sides by negative 3 over 2, because I want to make 1 here. So 2 divided by 2 makes 1, negative 3 divided by negative 3 makes 1. When I multiply by that negative, it's going to flip the sign. So I'll have p is less than or equal to negative 18 times negative 3/2. So it's going to be a positive 9 times 3, which is 27. So p is less than or equal to 27. So that's going to be a solid dot, and I want to say less than. Okay, so p is less than or equal to 27. For the next one, in interval notation, it would be negative infinity to 27, and with a bracket on the 27. Okay, for the next one, I'm going to start by multiplying through by my least common multiple, and it looks like on this one it's going to be 12. And so I'll have 2y less than, so when I multiply by 12 here, 12 divided by 3 is 4, so 4 times 2 plus y, minus 12 divided by 4 is 3 times y minus 1. And then I can multiply that all out. I'll get 2y is greater than 8 plus 4y minus 3y plus 3. And then again, we're going to note that these are the terms that contain the y, and these terms do not contain y. So we're going to get all the terms that contain y together on one side. So if I move over here, I'm going to have 2y minus 4y plus 3y is greater than 8 plus 3. So if I add that all up, I get y is greater than 11. So I can graph that on a number line. So strictly greater than 11, so we're going to put an open circle there on 11 and shade that direction. So the interval notation is 11 to infinity. And remember, we always have a parentheses on infinity because it's not a number. Okay, so this is for union and intersection. So if we want to do A union B, we want to say all of the elements of A contained with all the elements of B thrown in together into one set. So I'm just going to try to do them in order. So B contains 0, 2 is in A, 3 is in B, 4 is in A, 5 is not in either of them, 6 is in both of them, 8 is in A, 9 is in B, and 10 is in A. So that is the union of those two sets. We've taken all the elements of both sets and thrown them together into one set. The intersection would be only the elements that occur in both sets. So if I look at the elements that occur in both sets, I see a 6 in both sets. So the only element that occurs in both sets is 6. So it'll be just the singleton set 6. Solve the following compound inequalities. Graph the solution set, right, in interval notation. Okay, so for this one, I'm going to start by multiplying everything by 3. So I'm going to get negative 6 less than or equal to is strictly less than 6 times 3 is 18. Okay, and then I'm going to subtract 4 from everything. So that'll be negative 10 less than or equal to negative x less than 18 minus 4 is 14. And then I'm going to multiply everything through by negative 1. So I get 10. Remember, when you multiply by a negative, we're going to flip our signs. So x goes from negative 14 to 10. At the negative 14, we have an open circle. At the 10, we have a closed circle, and we're going to shade between. So the interval notation for this is negative 14, comma 10 with a bracket on the 10 because it has a closed circle. Okay, so for the next one, we have these two. So we can start here by multiplying both sides by negative 3/4. We're going to multiply by negative 3/4. So I'm going to get y is strictly greater than negative 24 times negative 3/4 is going to be 18, positive 18. And then this one, I'm going to get the y's on the same side. So if I subtract the y over, I get and add the 3 over. 7 plus 3 is 10, less than or equal to y. So y is greater than or equal to 10 is this one. And then greater than or equal to 10 or y is greater than 18. So that would be, include that. So since it's an or, it's that or that. So that means we're going to include both of them. So this goes from 10 to infinity. So then the next one is, I'm just gonna, this one has an and in between it, so it has to fit both of those to be able to work. So this is negative 2x plus 2 plus 4 equals less than x plus 3. So I'm gonna get all the x's on the same side. So if I add that 2x over, I'm gonna have 3x over here. And if I subtract that 3 over, 2 plus 4 minus 3 is gonna be 3. So I can divide by 3, and I get x is greater than 1. On the other side, I can multiply that 5 in. I get 5x plus 10 minus 3 is less than 4x plus 1. I can subtract the 4x over and subtract the 10 and add the 3. And I'm going to get x is less than 1 minus 10 plus 3. So 1 minus 10 is negative 9. Plus 3 is negative 6. So I need to have x is less than negative 6 and x is greater than 1. So if it's less than negative 6 and greater than 1, there are no numbers that fit both of those, right? So there are no numbers that are less than negative 6 and greater than 1. It has to fit both of them at the same time. So there are no numbers that do that. So the answer here is the empty set. So the solution set is the empty set. So we'll write it like that. So there are no solutions. So this is the empty set. Okay, so number 30 says the months of June, July, August, and September are the wettest months in Miami, averaging 7.83 inches per month. If Miami gets, okay, that, and that, how much rain is needed in September to exceed the monthly average for these 4 months? Okay, so what I want is that let's let X be the monthly average for September. So I want the monthly average for September to be greater than the average. So 7.83 plus 8.54 plus 5.79 plus x over 4. Okay, so if I multiply the 4 over, and I add those all together, 7.83 plus 8.54 plus 5.79, I get 22.16. and then I can subtract that over. I get 3x is greater than 22.16. I get 7, so I get x is greater than 7.386. That's different than what's on the key. I'm not sure about that. Okay, I'm just going to keep going. I'm not sure what's going on with that. Okay, so solve the absolute value equation. Okay, so I can subtract the 4 over and divide by -2. So I get 3y minus 10. So -6 minus 4 is -10. And if I divide that by -2, I get 5. Okay, and so what this means, if 3y minus 10 is equal to, so that means either 3y minus 10 equals 5, or 3y minus 10 equals -5. So I can solve for both of those. So 3y equals -5, so y is equal to -5/3. Oh, sorry. When I add, sorry, I'm having trouble adding here. When I add that 10 over, I get positive 15. So y equals 5. And then for this one, when I add that 10 over, I get 3y equals 5. So y equals 5/3. So those are our two solutions, 5/3 and 5. Okay, solve this one, graph the solution set and write the solution in interval notation. So let me scoot this over here. So I have 2x plus 3 is less than or equal to 30 divided by 6 is 5. So if I solve this, that means that I want to find the values where that thing is less than or equal to 5. So that means it's sandwiched between 5 and -5. So now I can add, I can subtract 3 from everything. And then I can divide by 2. Okay, and so then I get this on the number line, sorry, -4 to 1, and I fill it in there. So in interval notation, it's -4 to 1. Solve the absolute value inequality, graph the solution set. Okay, so similar. So 3x plus 5 is greater than, if I add that 4 over, I get 15. And so if it's greater than 15, that means it's either 3x plus 5 is greater than 15, or 3x plus 5 is less than -15. And so I can subtract the 5 over. 3x is greater than 10, so x is greater than 10/3. Did I add wrong here? 3x plus 5. (3x plus 5 is greater than 15, and I subtract 5. So 3x is greater than 10, so x is greater than 10/3. 3x plus 5 is less than -15, so that gives me 3x is less than -20, so x is less than -20/3. I'm missing something here too. Well, let's see, that's got to be a typo because the solution has y's in it, not even x's. So anyway, I'm just going to stick with that. Okay, so 34. A box of cereal is labeled to contain 16 ounces. A consumer group takes a sample of 50 boxes. Is that what this is, 50? Let me erase that. Yeah, 50 boxes. And measures the contents of each box. The individual content of each box differs slightly from 16 ounces, but by no more than 0.5 ounces. If X represents the exact weight of the contents of a box of cereal, write an absolute value inequality that represents an interval with which to estimate a box. So if X, so that means X is no greater than, so 16 ounces with an error of 0.5 on each side, so 16.5, and no less than 15.5. Okay. Solve the inequality and interpret the answer. Okay, so I guess that's the solution. This is the answer to part B. Okay, so for part A, we want to say the contents of each box differ slightly from 16 ounces, but by no more than 0.5 ounces. So we could say like X plus 0.5 is less than or equal to 16.5, 16, so sorry, wait, I want it the other way. X plus 0.5 is greater than or equal to 16. And X minus 0.5 is less than or equal to 16. So if I put those together, I get this thing here. So if I subtract the 0.5 over, we have X is greater than 15.5. And if I add that over, I get X is less than 16.5. So this is part A. These two are for part A, and that's for part B. Okay, all done.